And more power, baby. More power, baby. More power, baby. More power, baby. More power, baby.
Speed and power. Speed and power. A lot of power. 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 Powerful. Power. Monstrously powerful. Power. Ah! Power. 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 Speed and power. Yes! Feel the power. A cathedral of power. Power! Power! Come on!
Today, we're going to witness a great race at the Ferrari Dorm Stadium. 3 phenomenon cars are ready to go head-to-head on the single-use track I built. Behold our first challenger, the Nissan Skyline GTR R35, powered by a 3.8-liter twin-turbocharged V6 engine. With 562 brake horsepower, it accelerates from 0 to 100 in just 2.8 seconds. The second car we have today is the Audi RS6 Avant, powered by a 4.0-liter turbocharged V8 engine with 552 brake horsepower, accelerating from 0 to 100 in just 3.9 seconds, no question the fastest wagon on earth. Last but not least, the Lamborghini Reventon Roadster, powered by a 6.5-liter naturally aspirated V12 engine with 661 brake horsepower, accelerating from 0 to 100 in just 3.4 seconds, the most powerful car tonight. Yo, what is up guys? This is Peter from Mr. Baldeep's physics class. Now if I let you to predict the ranking of these 3 cars, what information would you value the most? And I think most of you would choose to look at this. But before we understand what horsepower is, we first need to know the concept of power in physics. Power is by definition the rate of doing work, which is calculated by dividing work done over time. Doing this gives you power in the unit of watts. Now that we know the first equation to calculate power, which is power equals work over time, then what is the second way to do it? As we know that work equals force times delta displacement, and then we can substitute force times delta displacement into work to replace that. And then we can get power equals force times delta x over delta t. Rearrange that gives us force equals delta x over delta t, and delta x over delta t is simply velocity. Now onto the topic of horsepower. Horsepower itself is another unit of power in which 1 horsepower roughly equals 745.7 watts. And by doing simple calculations, we can convert the horsepower of the 3 cars into power. And it is very obvious that the Reventon has the most power out of the 3 cars. Welcome to the Ferrari Dorm Stadium. The single-use track of 4333 will hold its very last race, so please take your seats and enjoy this race once and for all. Let the race begin.
See the future into the present. See my past is in the distance. Try to guess now what's going on, and the band begins to play. Deja vu, I just been in this place before. Higher on the street, and I know it's my time to go. Calling you, and the search is a mystery. Standing on my feet, so hard when I try to be me. Deja vu, I just been in this time before. Higher on the beat, and I know it's a place to go. Calling you, and the
Okay, now that you saw that the Nissan GTR won the race by a 0.1 second advantage. But why didn't the Lambo win the race? The theoretically powerful Lambo. And the problem is at its efficiency. Efficiency is a measure of how much energy is being usefully transferred in the process, which can be calculated by dividing useful energy output over total energy input, or dividing useful power output over total power input. And if you want a percentage, simply times the ratio by 100%. Then we can use this calculation to find out the efficiency of the three cars and try to understand why the Lamborghini Reventon didn't win. We have the input power of the three cars as we've calculated before, but how can we calculate the output? So we first need to have the data for the acceleration of the cars. And then I researched the mass of the three cars in kilograms. According to the work energy theorem, work equals delta kinetic energy. And kinetic energy is half mass final velocity squared minus half mass initial velocity squared. Now take the data of GTR as an example. Its initial velocity is 0 and its final velocity is 28 meters per second after converting the units. And put it into equation, it becomes half times 1,827 times 28 squared minus 0. Putting the equation into the calculator, we can get the delta kinetic energy of GTR, which is 720 kilojoules. Using the same method, we can calculate the work in kilojoules for the other two cars. In order to calculate the power output of the cars, we can simply use the equation work over time. And again, taking the GTR as an example, its work was 720 kilojoules and divided by 2.8 seconds, it gives us the power output of 260 kilowatts. And doing it the same for the other two cars. And finally, we can calculate the efficiency of the three cars using the equation output power over input power times 100%. And again, taking the GTR as an example, the equation is 260 over 469 times 100%. And this gives us about 62%. And after calculating using the same method for the other two cars, it is obvious that the GTR indeed had the greatest efficiency. So this is the end of the video, and hope you enjoyed it and learned something. And we've proved that Nissan has really done a lot to make this thing a really fast car. And at the end, please subscribe to Mr. Baldeep's physics class and keep on searching for speed and power.